Right, so I just made a live stream a few minutes ago, about an hour or so ago. I was talking to my friend on Discord, and I explained to him that well, I didn't tell him about this module, but this module is voltage and current limited. Right, just move. This is the meter I'm going to use for current. I've got it on the 10 amp range because the actual load is about 800 milliamps on the motor to drive this motor, which turns the belt drive, which turns the device. And this device is powered from this module here. Right, so this module has got two adjustments on it. If you look down there, it says CV. Let me just turn it around. It's got CV, that's constant voltage, and it's also got CC, constant current. Both of these are set up so that the output current and the output voltage can't change, which means that the input to this whole block, because this is the boost regulator, this is what steps the voltage up, but the chip blew up. There's a big chunk missing out of it, as I was showing in the previous video, but it's still passive, so voltage is still passing through and it's not actually draining any energy because this board is just not doing anything right now, so the power goes straight through. I left it in place because I plan on getting a new chip, desoldering it, putting a new chip in it. I just need to order one. Anyway, so my input goes in on the black and the red wires to this here, plus that's minus and that's plus. So what I'm going to do, I'm going to get my red wire, which is this one, right, and I'm going to connect it to the meter, which is on this big thing here. I've got this, whoops, just plugs in. Oh dear, hang on a minute. Looks like a blooming dragon, that thing. So just put that on there. Oh, how do I do this with one hand? Hang on a minute. I'll try and hang on, I can't do this with one hand. Just a minute, let me pop the phone up on something. Hang on. I'll rest it against my mouse. Stay. Right. Right, when I connect this to here, it will start the device, and then we're gonna take a new measurements when I actually disconnect the output, and we'll see what the current changes is on this meter. Just make sure everything's right. Looks like it is. Right. Notice the red light. Well, it's gone green now. It's green because the current limitation is going on. That's the current at the moment as it's speeding up. That's the input current. It will drop. It should drop to 800 milliamps when it gets up to speed. Oops. I'll leave it there. There's the RPM climbing. That's the output current. Because it's about the way it was last time, because the supercapacitor has got some charge in them now. So the LEDs are coming on. That's the input current to the motor, to that. I'm waiting for it to settle down. So it's finished its climbing in speed. So I've just got to let it settle down for a bit, still climbing. As I say, it's accelerating because it's inertial forces. So When that stabilizes, the output now 6,000. Input to the motor almost at 800 milliamps, which is usually hovers around 800 milliamps once it's stabilized and everything. Right, I think it's stabilised now. Right, so when I take the load off, we'll watch what current input is. Right, watching the output there on that, oh, that stupid meter again. Right, taking it off. It's not connected now, look. Output is minus. Very little change actually. As I said, there's a slight there's a very slight increase in RPM. But it's nothing compared to 300 RPMs that I was getting previously. That's the previous changes that I was seeing. I was seeing a massive change previously, and I'm only seeing a very small amount now. It's insignificant. So RPM is 6,162. Well, that's very small change considering for I was taking 50 milliamps out before. Right, let's just connect up because it seems to be stabilized again. Let's see. I think it's stabilized. We're not taking much. Right, let's reconnect this. Ooh, these clips are affecting the rotors. I can feel it on the clip. Right, that's ooh. Right, small amount of change, not much. And what's the output? 47.2 milliamps, 47 milliamps input. Yeah, but the point is, I used to lose 300, 400 RPM when I put that load on it. But we're not seeing that now, not like before. It's much more efficient. I mean, it's barely 50 RPM. I mean, it's around 6,100 now. Maybe 30, 40, maybe 40 milliamps difference on the input. The current limiting should be working, but mind you, since this thing blew up, I don't know what's going on with it, but yeah, this chip blew up and it's, yeah, might be affecting things, I don't know. Anyway, the current, constant current, I might need to trim that preset just to make sure it's working properly. That was my positive. Let's adjust the constant current because this might not be working right. Let's find it. Frigging wire. Ah, that's dropping there. I need to set it around. Right, I lost a bit of RPM then as I was adjusting my constant current. Now it's at 6,062. It dropped a bit then, so my constant current was a little bit off. Right, it's reset now, and that's my current input right now. Okay, right, 780 milliamps. Now let's take the load off, disconnect this, watch the LEDs go out. They're actually on supercapacitors now. Right, output is minus, because the supercapacitor is discharging through the LEDs. Well, that doesn't make sense. My motor's making some rattling noises. I'm actually drawing less current. What the hell? This doesn't make sense. It's not working like it was before, because now I've adjusted the constant current, the current is actually less slow. Let's just connect this back up again. RPM. Right, I'll put that back on again. Right. Output. Right. Anyway, it's better than it was. I'm sick of looking at that stupid video.
or the reason why I'm calling you right now is just to simply inform you that our
I'm watching Shangu. Um, right, so the current limiting is working now, but it's not dropping 300 RPMs like it used to do. That's the point. I used to lose like 300 RPMs with this kind of a load, and that's not happening now. Supercapacitors are charging up though, so that's another thing. They're actually getting charged up. Right. Anyway, a little test, a little update, just to add on to the other update, because my friend wanted me to measure the input current. Yeah, well, there is a difference. There's a slight difference, but it's not much of a difference. And anyway, I've got my constant current set properly again, because since that thing blew up, it's knocked things out of kilter a little bit. That's probably why. Anyway, so now I've got that constant current reset. We should have a limited current now on there. Let's just disconnect this again, see if we do. Yes, we do have limited current. It's not exact, it's this Chinese junk, just not very accurate, but it's limited a lot better than it was. Right, and the speed's gone back up again a little bit, but not as much as it used to do. But anyway, we're getting there anyway. I'm confident. Put this back on because it gets me depressed when I feel like I'm not getting anywhere. Right, okay. Right, that's it for now. So yeah, with all that noise going on, because it's not that noisy really, but yeah, there was a slight problem with my constant current, but I've got that set right now. It's much more accurate than it was, and it is doing a lot better than it used to do anyway. A lot better than it used to do. I can't get this off without, I'll just end the stream now anyway. So we've got more things to do. I've got all them other coils over there in the distance, all that them coils there. Got to fit all of those in at some point. I've got some laminations to sort out somehow. Either I'm gonna have to cut some by hand, or well, they shouldn't be too difficult because I just want U shapes, and I've got a load of tin sheet steel which I can probably trim some bits out of. It's not going to be a job I want to do right now. I don't feel like doing it right now. Otherwise it would mean something like 80 quid or something ridiculous to get some cut by laser again. I just can't afford that right now. Yeah.